Hello everybody! Today we will speak about microcontrollers. I will try to explain to you basically what is a microcontroller, how it works, and its applications. First, I will show you my personal notes that I will use for this exercise. And second, I will show you the vocabulary that we will learn today. First, we have to turn off. Is similar than to shut down when we are talking about machine. Quickly is when we are talking about speed of something. Several is when we are talking about amount of something. Blank slate, behind, and even. So now we can explain what is microcontroller. A microcontroller is like a very basic computer. The principal differences between both are that a microcontroller is much simple and has much less power than a personal computer. On the other hand, personal computer can do a lot of tasks in the same time or works in a lot of software in the same time. But a microcontroller can only do one task or can only execute one code at the same time. So for this reason, microcontroller for some application can run quickly and efficiently in comparison with personal computers. For example, if we have a machine that have to do always the same task, is better organize the control with a microcontroller than with a PC. So I will try to explain you basically what are the different components inside a microcontroller. First, we have a processor. It is also called a CPU, Central Processing Unit. It is the component which executes the necessary calculations in order to different tasks. The CPU is the most important component. The second component is RAM storage. RAM storage, it is also called volatile memory, and his function is to calculate data temporarily. So as soon as the system is turned off or shut down, this data disappear. This data is lost. The third component is the flash storage. It is also called permanent memory in comparison with RAM storage. It stores the data even if the system is turned off or shut down And, we have hardware peripherals. We can connect by the GPIO pins of the microcontroller, some sensors or circuitry. Another electronic circuitry. For example, if I connect to my microcontroller a temperature sensor, this sensor will measure the external temperature and will send to microcontroller an analogical signal. The microcontroller will transform this analogical signal to a digital signal, and after if we want to do a more complex code, we can show this number of temperature in a LCD display. And the last important component of a microcontroller is the clock. The clock determines the speed at which the CPU executes the instruction. For example, if we say that clocks run at 16 megahertz, we are saying that the clock. This means that the CPU clock ticks 16 million times per second, and on each clock cycle, the CPU can perform a simple instruction. This work is called machine cycle or cycle machine. If it then groups there's simple instruction together to do bigger tasks like displaying data or reading an input. So every machine cycle there is an internal electrical signal clock on the chip, which goes up and down at set internal, and every time there is a clock edge. When it changes states, it's as a new cycle. And finally, the applications, the principal applications of microcontrollers are, for example, in industrial instrumentation, for example, with a voltmeter, we can measure an electrical signals. Or thermometer, a digital thermometer, we can measure temperatures. The internal calculation are realized by a microcontroller. Another application example is to control some industrial machines. So, and another example is domotics for an automation for the houses. And the last application that I want to take about is a home appliance. For example, washing machine, television remote control, etc. So that is my presentation about microcontrollers. Thank you to listen.